right, so we're interested in the line tangent to this curvy line uh, that's parallel to this straight line right here. So what we need first of all is the slope of the straight line. So we'll translate that into our familiar slope-intercept form, y equals mx plus b. And all we're after is m here, the slope, because the parallel line, or sorry, the tangent line that's parallel will have the same slope as the line that we have in the diagram. So we'll just rejuggle the y and the x so that the y is on the left and the x is on the right, and divide everybody by 3. And we have y equals 2/3 x minus 1/3. And all we're interested in is this number here. We're just interested in the slope, and we can just throw everything out. That's all we wanted from that line. So now we can actually change this question. We can reword it now into find the line tangent to a curvy line that not that is parallel to such and such, but just simply that has a slope with a 2/3 slope. Because that's, we've gotten everything that we need out of the equation for a straight line. Okay, so we've got the slope is 2/3, and we have the function, the curvy function, which we're going to take the derivative of that. I'll just write out the whole thing again here. And we want the derivative because that will give us the slope of the function at whatever value of x we plug into it. So a derivative of 5 is 0, and derivative of e to the x is just e to the x, and derivative of a half x, just a half. And now we want to know about when this is equal to 2/3. So we'll set that equal to 2/3 and solve that equation. So let's see, the 0 drops out, and we let's put the x term all on its own, 3e to the x, and that adds up to, that equals 2/3 plus 1/2, and do some arithmetic. 4/6 plus 3/6, and that equals 7/6. All right, so that's what e to the x equals, 7/6. Sorry, that's what 3e to the x equals. So 7/6 times 1/3 is our e to the x. And then we're going to take the logarithm of both sides, because the log and the e cancels out. We get x equals the log of 7/18. And that's as simplified as we get for our x. Okay. So we'll just take a note of there. And now we want to know the point on our curvy line that goes where the tangent line that we're after touches the curvy line. So we'll plug we'll take rewrite the curvy line equation, but plug our x value into it. This starts to look kind of messy, but this part will actually work out really nicely. Minus 1/2 of log 7/18. All right. That we're going to see that term a lot because we can't simplify it anymore. So let's just do what we can with these first two terms. So that equals 5 plus 3 times, now the e and the log, they do away with each other, and we just keep the 7/18. Okay. And the minus 1/2 log 7/18, nothing new happens to that. And we end up with, let's see, 5 is 90/18 plus 3 times 7 is 21/18 minus 1/2 a log of 7/18. Okay. And now we'll just put together these two fractions. 90 plus 21, that's 111 over 18 minus the ever familiar 1/2 log of 7/18. Okay, so what is that? That's the y coordinate. Okay, for the point on the curvy curve that we're interested in. And so let's suppose that point is right around there. We can now label it. The x coordinate is the log of 7/18. That is a comma. And the y coordinate is this expression here, 111 over 18 minus 1/2 of log of 7 over 18. That's as simple as that gets. Okay, and now that's the point that the tangent line that we're after goes through. Okay, and now there's the line. Now we'll use the point slope form to convert all of the information that we've gathered into the equation for a line. Okay, and now let's plug everything in. Okay, so we have y minus this expression down here, which is 111 over 18. Then minus is a positive, so plus 1/2 of log 7 over 18. Okay. And that equals the slope that we previously determined is 2/3, and then our x minus the x term, which was log of 7 over 18. And that's the equation for the line tangent to the curve that's parallel to the other line. So Bob's your uncle. And here's what it looks like when it's all prettied up. And like, subscribe, comment, do all those things. And we'll see you next time. Cheers.